Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to show you how to process mooring simulations in parallel using our batch tool, ProteusDS Queueing Manager. We're going to use the data well template mooring for this exercise. And what we have here is the schematic view in ProteusDS Oceanographic Designer, just to give a look at a mooring there. It's 200 meters water depth. And previously we've already exported some simulations here for ProteusDS Simulation Toolbox to analyze the system in current and then also in waves. So we have one case already set up here. If you take a look at it in ProteusDS Simulation Toolbox, we'd set it up to run with an irregular sea state, 5-meter significant wave height, and a 9-second peak period. And here's the wave seed, which is the number that initializes the random number generator used to create the time series of the wave sea surface from the John Swap spectrum for this specific simulation. Now, quite often it's a good idea to run a few cases with a few of these different seeds just to check the peak loads and see how they vary between the two cases. But there's many other reasons to run more than one case. Maybe you have a different current profile you want to check and see what the mooring does in that response. Maybe you have different sea states, the maximum wave versus the steepest wave you have at a site. So there's many different reasons to do that. So these are just folders in Windows Explorer. So I'm going to make a copy of this, and I'm going to make a couple of extra folders. Copy, and then paste, paste. I'm going to change this to wave seed 2. In this case, I'm just going to make a change only to the wave seed values because I just want to get an idea of like how do the peak loads change, and that's a good reason to run a few different wave seeds. So you can go into ProteusDS Simulation Toolbox, but be aware that you can actually edit these files. They're just text files. I don't always recommend this if you're not comfortable with it. Don't do it. But you can change the wave seed pretty quickly this way. And this number, it just has to be an integer. As long as it's different than the other numbers, it'll give you a totally different representation of that time series. So maybe you just do 1111. We'll save that. That's a different seed, wave seed 2. Then edit. I'll change this to 2222. Save. So they're different wave seeds. Now, how do we run these? We've got 3 cases. As you get more and more and more cases, it kind of becomes a bit of a pain to open each one in ProteusDS Simulation Toolbox and run them individually. That's why we've got ProteusDS Queueing Manager. So if you type ProteusDS Queueing Manager, you'll see it come up. And it's a very simple tool. The quickest way to get items in here to simulate is you can select them all in Windows Explorer and then left click and drag them into PQM. This is a great little drop down menu. That's how many available computational cores you have available. If you've got hyper-threading on, you'll see more than the physical cores, and that's how many are going to run in parallel. Don't recommend using all of your cores because it's hard. Your computer won't really be very usable if you do that. But just for example, I'm going to pick 2, and then you just hit go. And you can see this one is queued up for later, and you can get the same kind of information about what's happening with the simulations from this little window here. If there's a problem, it'll tell you their problem. You can stop the individual simulations here. This X means it'll stop any new processes from beginning. But it'll allow these ones to finish off if it can. So this is great because obviously the more cores you have, the more simulation cases you can run in parallel. And it really saves a lot of time and a lot of headaches when you're just trying to get some simulation results going. So that's what I wanted to show you. I wanted to show you how PQM works and how to get something up and running really fast. Thanks for watching.